Hello, everyone. Welcome to Best Practices for Amazon S3. My name is Rob Wilson. I'm a product manager on the S3 team, and I'm joined by a few other speakers today.
Hi, I'm Shikha. I'm a software development manager in AWS S3.
Hi, I'm Matt. I'm a senior site reliability engineer at Instructure.
Excellent. So they'll come back on later on, and I will lead you through the beginning of the presentation today. We've got a great agenda for you. We've got a lot of different topics to cover. But as we go through it, we'll try to cover a few best practices on each section, so there's something for everyone in the audience, whether you're new to S3 or whether you've been using the service for years. There's also a number of breakout sessions throughout the week on related topics. So security, performance, cost optimization are big themes that you're going to see in a lot of our sessions throughout the week, and they can go into more detail in those sessions than we will today when we're doing all the best practices across S3. So these sessions in particular, multiple editions of them throughout the week, so take a look at your schedule and hopefully you can make it to some of those as well. So let's start with an overview of Amazon S3. This will be a pretty quick section just covering the basics, but we'll dive into a lot of these topics later on. On this slide in particular, there's many benefits to Amazon S3. The one I want to mention today is really the scalability, though, because it's really exciting that customers can get started immediately, create a bucket, start to store data in it, and you can grow to petabytes or more without thinking of hardware, capacity plannings. You just have the storage scale as you do. So then we'll talk through some features that help you manage that scale as you continue to grow on S3. Because of those benefits we just talked about, we have customers from virtually every industry using Amazon S3. That includes things like Internet of Things, data lakes, media content, user-uploaded content. So you're probably using many of these today in different workloads yourself, but the customers to the left and right of you are using S3 in different ways too. So really interesting to learn from each other at reInvent while you're here. And once you decide to move your data to the cloud, we've got 11 different features that can help you do that. I'll highlight a couple now. You can really focus on the Kinesis products and Kinesis services for streaming data. And one of the more interesting things you can do with Kinesis is say, I've got a lot of small files that I want to store in S3, but it might not be efficient to store small kilobyte, bite-sized objects in S3. So using a service like Kinesis Data Firehose, you can actually batch those objects and write larger files to S3. So it can be more efficient, easier to manage from a storage standpoint, and then you can aggregate those over maybe 15 minutes, maybe an hour. You can kind of customize the buffer in Kinesis there. The other one I'll highlight is the ability to physically transfer data to AWS. So when the network connectivity is not there, and when it would actually be quicker to ship the data, you've got Snowball, Snowball Edge, and Snowmobile. So you've got all those as options as well. Now we'll jump into a discussion of our storage classes. A lot of different decisions could lead you to use our different storage classes, and I'll try to talk through those now, and we'll really deep dive on intelligent tiering. Up here on the slide, you see that since 2006, we've constantly innovated to make your storage easier to manage and also more cost-effective. So on the left side, you see an over 80% reduction in the cost of S3 standard since we first launched in 2006. And on the right side, you see how we continue to add new storage classes over time, most recently with intelligent tiering, last reInvent, and then Glacier Deep Archive earlier this year. So with the introduction of those two new storage classes, you've now got 6 storage class options. And I'll walk through some of the major differences right now, but I think the lesson here is when you've got 6 choices in storage classes, you want to be thinking about what part of my data might belong better in one of these storage classes? How can I save money when I'm storing more and more data in the cloud? So starting on the left side here, you've got S3 standard. Millisecond access, 3 or more availability zones. There's no retrieval fee for the data, no minimum object size, no minimum storage duration. Standard is a general purpose storage class. It's where a lot of customers start out. They put all their data in standard. So you might have buckets where you have 100% of that data in standard. They might be something where that bucket was created 10 plus years ago. But when you start looking across at some of the other choices here, usually there's some data in that bucket that's really cooled off. Maybe it was accessed a lot for a few weeks, and then after that, it's not being accessed much anymore. So let's look at those infrequent access storage classes in the middle. Standard infrequent access and one-zone infrequent access. Both are optimized for that less frequently read data. There's a per gigabyte retrieval fee for these storage classes, so you get the lower storage cost, but then you're paying a cent per gig to retrieve the data. So when you look at the price of standard and then the price of the infrequent access storage classes, it's about a 1-to-1 ratio that you want to look at, where if you're retrieving data about 1 time or less per month, it's probably a good fit for infrequent access storage classes. So you'll be about indifferent between the price. But you'll probably have a lot of data within your bucket that's only retrieved, a handful of times a year or less. So really you want to think about, how can I move that data to the infrequent access storage classes and save some money? And then on the far left of this slide, you're looking at Glacier and Glacier Deep Archive. Much lower price point for your storage, so it's great for those compliance and archive workloads where you might say, I have to hold on to this data for 5, 7, 10 years for compliance purposes. Some data you might need to hold on to indefinitely, and chances are you're probably not accessing it a lot after those first few months, years, etc. Glacier Deep Archive offers you an exceptionally low price point, about $1 a terabyte per month. So we have customers now that are saying it's almost cheaper and easier for me to hold on to the data than it is to delete it at that price point. One of the storage classes I didn't mention, though, as we talked through this slide, is intelligent tiering. So let's take a look at that now and see how that works. This was launched about a year ago, and it's a storage class where you put the data, and then we move it between a frequent and infrequent access tier. So everything starts in the frequent access tier when you first add it to the storage class. After 30 days, if an object is not accessed, it moves to the infrequent tier. And the most important thing to remember there is it's doing this at an object-by-object basis. So if you put 100 objects into intelligent tiering, and 2 of them are read all the time, you've got applications, you've got users who just keep reading those 2 objects, they stay in the frequent tier. The other 98, though, if they're not accessed, they're going to move to infrequent tier. And now you get a blended savings that's between that frequent and infrequent tier, and we'll go through the details right now. So the price of the frequent tier is the same as S3 standard, so pretty simple to remember there. And then the infrequent tier is priced the same as our infrequent access classes, standard infrequent access in this case. So you can save up to 40% by using intelligent tiering. It's completely hands-off to you, and as data is not accessed for 30 days, it moves to that infrequent tier. So how do you get closer and closer to that 40% savings? Well, you do that by having more and more of your data infrequently accessed. That's obviously one of the ways as more of a tiers down. But also you want to think about moving potentially larger objects to intelligent tiering. There's a per object monitoring fee, because we're looking at the access patterns on all these objects that you move to the storage class and doing that tiering between the classes. So when you have objects that are megabytes or more in size, that per object monitoring fee is now much lower relative to your storage, because there's more storage there, not as many objects to account for that same amount of storage. If you have objects that are byte size, kilobyte size, you may not save as much in intelligent tiering because that monitoring fee may be a little larger relative to the storage. So that's something to think about. And I think the bottom line here on intelligent tiering is, first of all, you've probably got a lot of workloads that really fit this pattern well. Anytime you don't have a good idea of the access pattern, anytime it's changing, anytime it's too complex to really design rules around the access pattern, you want to consider intelligent tiering. And one of the best parts is it's entirely transparent to your end users. So if your end users won't know if you're in standard, in infrequent access, or intelligent tiering. So it's savings that you get, and your end users get the same performance that they would have gotten anyway. And just to highlight, we've got customers that since last year are using this in a major way across their applications, across different workloads. So really take a look at whether intelligent tiering is a good fit for you. Now, if you have data that might not be a good fit for intelligent tiering based on some of that discussion, or you think you have a very defined access pattern, it might make sense to actually use lifecycle policies and some of these other features to move across storage classes yourselves. So storage class analysis is a feature designed to give you those insights into your access patterns. If you've never tried this feature before, I'd recommend turning it on for one of your larger buckets. So a bucket where you've got a lot of storage, it might be all in standard today, and you say, I have a suspicion, I've got colder data, but I don't want to do the work to manage all of that myself and to get those insights. What this feature will do is, after 30 plus days or so, it's going to give you a recommendation. It's going to monitor the access over that period of time, and then you're going to get a view similar to what I just showed here on the slide. So objects that are 60 to 90 days old, you see that the amount of access relative to the data stored, there's more access happening relative to the data. So that's above that 1-to-1 ratio I kind of talked about. Whereas after 90 days, the access on this data drops off considerably, and you can see that right here. And this feature will show you the view across many different object tiers. So this customer, if they see that pattern continue after the 90-day threshold, would likely write a lifecycle policy saying, after 90 days, move to infrequent access to really start saving money because this data is not being read very often, and that retrieval fee is not going to matter much at all at this scale. Lifecycle policies that I just mentioned, here's how they work. So you might take that recommendation from storage class analysis, or you might know enough about your data to just write a lifecycle policy. And what this is a rule to move your storage to another one of the storage classes. In this case, I put up a pretty common example, which is I have data that lands in standard, likely. For the first 30 days, it's read by different teams, different applications. It's pretty active for those first 30 days, so I leave it in standard. After that, though, I see a considerable drop-off. This is something where the data is really relevant for that first month, but then it kind of drops off. After 30 days, I move it to standard infrequent access, because I still want it back in milliseconds. I still need to have it available if somebody needs it in a hurry. But then after a year, maybe this is log data, maybe it's a backup. The chances I'm going to need that log or backup after a year, pretty low likelihood, but I want to still hold on to it. So that's where a customer might move it to Glacier Deep Archive. These are simple rules you put in place. Now it's automated. You're not thinking of objects. You're just putting them in the bucket, managing your application, building new things. And then this policy takes care of the work for you, and you'll see the savings. A way to get a little more detailed with lifecycle policies is to use prefix and tag-based rules. So here, you can now write a rule that applies to all tagged objects, such that they don't need to be all the objects in the bucket. They don't need to align by a certain naming scheme. But you can say every time an application writes an object over 5 megabytes to S3, maybe you want a specific rule for that, so just add a tag. And every time you put an object, put a certain tag that maybe says the object size, the application, the type of data, apply the tags that are most meaningful to your business, and then your lifecycle policies can then only take action. You could write them to only take action on the tagged objects. So a way to get more granular there. You can use batch operations, a feature we'll talk about later on, to apply those tags in a major way. So if you want to tag millions of objects and you say, how do I even get started? Batch operations will do that for you. And then the last thing I'll mention as we kind of look at the example here of just how easy it is to write a tag policy is that when customers look at, I might have hundreds or more prefixes across my bucket, I might have many different teams there, I might have many different combinations of lifecycle rules. It can be complex to manage all those different rules for all these different prefixes. But if you've got more commonalities across the bucket, then using tags might allow you to take hundreds of lifecycle rules and make it maybe 10 or 15 lifecycle rules. So that example we looked at before, standard infrequent access to Glacier Deep Archive, if that's a pretty common pattern across your bucket, you could tag all the objects that meet that rule. You could tag objects differently if the standard infrequent access transition is 90 days, maybe the Glacier one's 3 years. So think of those different transition combinations you want to set up, and then use tags. So now it's simpler, it's a lower number of lifecycle rules you're managing, and then you're that much more tactical in how you're applying the rules. On this slide, we'll really cover performance at a high level, but I wanted to mention a few of the main best practices to all of you in case you're not able to attend one of the other sessions. So the first one, this is likely the easiest for you to adopt and get started with, is just using the most recent version of the AWS SDK. This comes with automatic performance enhancements, such as handling timeouts, managing automatic retries, and then probably most importantly, especially when you're handling larger objects and larger pieces of data moving in and out of the cloud, is parallelizing the uploads and downloads. So using multi-part uploads, using ranged gets for the download, you're going to improve performance, really take advantage of how S3 can scale with UDO and really gives you an ability to horizontally scale. And now you're just going to see that improvement by using the SDK. So instead of doing something in sequence, for example, you might see a big performance boost by just using the SDK. The other ones I'll mention about here, and we have a white paper to cover these as well, is scaling horizontally for more throughput. So you can have many, many connections to a single bucket in Amazon S3. Really design your application in such a way that you're grabbing as many of the objects as you need right up front. Don't wait to get all the objects. If you've got instances waiting on your data, really think about how you can fan out those requests to get more data faster and start processing it downstream. The other one is thinking about caching your data. So if you want lower latency access, higher throughput, it might make sense to use something like CloudFront, Elastic Cache, maybe Elemental Media Store to cache some of that data that's used most frequently. You can still pull back data from S3 as needed, but you might save a little bit on requests, and you might get slightly better performance by using some of those caching solutions as needed. And then transfer acceleration is a great fit when you're moving data across continents, for example, or when you're moving data long distances to or from an AWS region. This is going to give you a performance boost by using the AWS network and really transiting that as far as you can towards your end users. So you get a little bit of a speed improvement typically from using that. And there's a great website that you can just check out to test your speed at any point in the world and how transfer acceleration might be able to enhance the speed. And as I mentioned before, there's a few other sessions. So here's a few of the different ones to look up in the catalog to go see more on performance throughout the week. Next, we'll dive into security. And here I want to talk about the granular controls that we give you to manage access to data in S3. S3 is secure by default. Your buckets and objects are private by default. And then we give you those tools to then manage access and share it with others. So talking through this slide and then diving into a bit more detail, block public access is the way to say, for this bucket, for this account, I do not intend any public access to be granted through access control lists, through bucket policies. It's a blanket setting that we recommend even if you have a private bucket today. If you created a bucket in your own account, everything's locked down, and you say, I'm perfectly comfortable, well, if you don't intend public access, it's still good to put block public access on here in case something changes. In case there's a misconfiguration, in case somebody just adds the wrong characters to a bucket policy, having block public access is then that umbrella that gives you one additional layer of security. Then when we talk about encryption, there's the ability to set up encryption by default for a bucket. There's the ability to audit the encryption of objects using S3 inventory. And then you've got bucket permission checks, both in the S3 console and then also in Trusted Advisor, giving you an easy way to look through your buckets and see their status on whether they're public or private. So here, just recapping a few of the layers of access control, and I'll put up a recommendation at the bottom here. I mean, we absolutely recommend customers use bucket policies and use user policies. So this is the common access language across AWS, and it fits better with what you're using with other applications. And when you look at object ACLs and bucket ACLs that I have at the top, they're not going to give you the same flexibility and controls. Object ACLs, you can grant read permission to objects, but really nothing else. And then when you make changes, you've got to think about making that change to all the objects that are affected. Bucket access control lists, you can give write permission, you can give list permission to the objects in your bucket, but once again, not very flexible. You can't go down to the prefix level, and it's not giving you that same flexibility as the policy. So when you're thinking about access controls cross teams, within a single team and to individual users, you can get much more specific in those policies, and that's what we recommend you do. Here, we'll dive into block public access. I want to emphasize that the account level setting is so powerful because it applies not only to existing buckets, but to new buckets. So if you're an administrator or someone else managing the storage environment, you've got many different teams creating new buckets. If that's all meant to be internal data, shared only cross-account, everything explicit permissions, just put block public access in place. And then there's 4 different settings, which we'll go through in a second, because you might want to set all those settings, or you might want to set a combination of them. And then AWS organizations, using a service control policy, gives you the power to say, I set up block public access, now I want nobody to be able to change it. You can deny the ability for anyone to make changes at the org level. So now that account root user even can't change block public access, can't remove it. You've put that protection in place. So when we talk through the different settings here, it goes back to the ACL and bucket policy discussion we had before. If I want to block any new public access control lists from being put into my bucket, I enable that first setting. That means if somebody tries to upload a public object, it will be blocked. It will be denied at that point. The second setting is much more about existing permissions, such that maybe I already have public objects in my bucket, and somebody uploaded them years ago, and I've got them there, but it's not intended. I just turn on that second setting, and even though a request is coming in that would have allowed in the past, now block public access will override that, and there won't be any public access. The third setting is blocking any new bucket policies. So if somebody tries to upload a new policy, it contains some public access, it'll block that at that stage. And then the fourth one is then going to block any public access granted through existing bucket policies. So you've got the flexibility to choose what you need here, but for a lot of customers, we find that enabling all of these settings is usually the right configuration. Default encryption, Fairly simple, as the title implies. You enable at the bucket level. Any object that's being added to that bucket that doesn't have encryption specified gets the default encryption applied. So if I enable default encryption with the server-side encryption S3 keys, and somebody uploads with KMS encryption specified, then the KMS encryption will stay as specified by the put. But any other objects without encryption specified get the default. So this is an easy way that you can just say, I want everything encrypted in my bucket, here's the setting I enable. And then we can talk through some differences and some ways later on how you can encrypt the existing objects in your bucket as well. Access Analyzer, brand new launch from yesterday, is going to help you visualize what buckets offer public access, what buckets offer cross-account access, give you details on what type of access is permitted, and then enable and help you to remediate those and take action, including enabling block public access right from that view. So this will give you a console view and a CSV download, so you'll be able to see that level of detail about your buckets and access. Here's a console view just to bring it up for you. This is a bucket where there is public access granted, so a user is going to see that right away when they log in. In this case, one of these buckets allows list and read permission. The other one allows write, read, and list. It's going to tell you whether it's an ACL or a bucket policy that allows that access. And then you see the bucket up there for block public access. You click on the bucket, say block public access, you've now remediated that. You can also use this list in an interactive way to say, that's the bucket where I host my static website content. I intend for it to be public, and you can archive these results such that you can view them and go back to them. But if you want to maintain the most meaningful list of what do I need to take action on, there's a way to say, I acknowledge these are correct. I know I need to fix these. And this is really a way to go through and take a look at all your buckets across regions and really dive in. And then on the bottom there, something new from the S3 console and Trusted Advisor today is also giving you the same visuals into cross-account access. So before, we were really focused on showing you what buckets are public or not. Now it's going to allow you to see buckets as well that are shared across account, and you can go through and do the same process to say, is this correct? Verify it's correct, and then mark it as such, or remediate as needed. The other new launch, brand new from today for those interested in the security topic, is access points. Brand new way to grant access to your S3 bucket. Great, as Andy emphasized, for data lakes. So you've got many different teams and applications accessing a single bucket. For those of you who use S3 a lot today, you've probably run into situations where you're having everyone use the same bucket, and now you've got a bucket policy that has to handle all the different combinations of users. With access points, you can get much more detailed about which users are using which access point, and then write policies specific to them. There's also the ability to make these VPC only. So if a bucket should only be accessed through a VPC, you can enforce that only VPC endpoints are created, access points, and then you can take the default endpoint that's there today and just block access through that and enforce that all access happens through the access points. So it's a way to very easily enforce your VPC compliance needs using access points. So this is a feature where we want to dive into some more detail, and I'll talk through some of the other benefits here. You can create hundreds of access points for a single bucket. You can specify that they only belong with a certain VPC and can only be accessed through that VPC. You've got the ability to set block public access on an access point. And then this is account and region local. And for many of you, that's going to mean that you can use the same names across regions. This is not a global bucket namespace where you're just taking what's available. This is, I want to test access point in all my different regions. I want my applications to know that in this account and this region, there's going to be an access point with that name. So you can reuse that name across different regions. Gives you a ton of flexibility when you're building. And I want to talk through some different benefits here. So previously, we had this single bucket endpoint, so to speak. It was through the bucket host name. You didn't have the flexibility to control it in different ways. And everyone's access was controlled through the same bucket policy. Here, you now see that there are different teams using this bucket, and all of them have different access needs. So we've got finance, sales, supply, data science, and you might have a different combination of read, write access. Some users can take other actions than others. You can then name the access points distinctive to those groups, give those groups access only through those access points, and then On the right side, you see that, well, finance should only be able to access the prefixes associated with their data. Sales can only access their data, et cetera. And because you have a policy attached to that access point, you're only managing their access through that access point, allows you to be much more granular, much more detailed. You know exactly where you need to go to refine their access. And now you have that much more flexibility to provision a large bucket, perhaps a data lake, perhaps another use case with a lot of different teams. You can get so much more specific. You got the VPC benefits as well. And in this example here, we see that case that I talked through earlier. We had the bucket host name, basically the bucket endpoint, that was the default one existing today. I don't want any access through that. I just want access through the VPC. So I create 2 new VPC access points. And then I use the bucket policy to enforce that no access is through the default endpoint. All access is through access points. You can also set at the organization level that all the access points have to be created to be VPC specific. You've got all these different controls to get exactly what you need done with security to your S3 bucket. Really exciting new launch. And we're interested to hear how all of you are using it. The next section I want to talk about management. We talked about scaling your data earlier, and these features are all about managing data at scale. The S3 inventory is an alternative to using the list API. So for those of you who are familiar, if you want to list millions or billions of objects, that's a lot of API calls at 1,000 objects a time. And if you're just trying to build that list to then run analytics off of it to do an audit, that's a lot of work just to build the list. Inventory, a managed feature, you say, I want this list delivered daily, maybe I want it weekly, and look at all the metadata it can provide you. It's the basics like creation date, storage class, the key name of the object, that's as expected, but it's also the intelligent tiering access tier. I put all these objects in intelligent tiering, I want to see which ones are moving between frequent and infrequent tier. If you want to go to that level of detail, this is going to give you object level visibility. Replication status is going to be shown here, and then things like object lock as well, another feature we'll talk about later on. You want to know the details about your objects, this is a great way to do it. And an example that we mentioned briefly earlier is I turn on default encryption for a bucket. I now know everything's encrypted moving forward, but what do I do about the 10 million objects that someone uploaded a few years ago? Do I have to build my own tool? Do I have to do something else? Well, here's the starting point. Get your inventory report, run a simple query to say, I want to see a list of all the unencrypted objects. Now you've got that list. It was quite easy to run. In this case, I just grabbed the bucket, key name, version ID, and now I've got an authoritative list of all the unencrypted objects. So what do I do with that? I use this feature to then encrypt them. So batch operations is a feature designed to perform an operation across thousands, millions, billions of objects. Managed solution, you say these objects do this action, and then you get the visibility along the way of how far along that job has proceeded. Are there failures, successes? Everything's packaged into this tool. So in this case, where a user might say, I have unencrypted objects, I want to encrypt them, we would just use the copy operation. We'd say, I'm going to copy those back to the same bucket. It's going to overwrite the unencrypted objects with the new encrypted ones. So that's one way you can tackle this. Or a user might have a version bucket, so then you might have a lifecycle policy to clean up the old versions. But that is a way to quickly get to encrypting all your existing storage by just using Athena, inventory reports, and batch operations. No real code writing on your part, just connect it all together in the cloud. And talking through batch operations in a different way, just showing you the sequence, you can give it a CSV list, or you can just hand the inventory report as it is. If you want to perform an action across a whole bucket, take your inventory report and then say, here's our next step. You can do things like copy, add tags, or run Lambda functions. We'll go through that in more detail in a second. And then, as I said, you not only get the visibility of how far along that operation's proceeded, but you also can get a completion report. Customers have been really excited about that completion report because it gives you the flexibility to say, I want a record of everything that batch operations did. Or you say, well, I'm running it across 1 billion objects. I don't need 1 billion, like, good to go. I need to know that if 150 of them failed, which ones are they? Why did they fail? And then I can go back and correct it. So we actually separate the success and failure objects in the completion report. And you can say, I only want a report of the failed objects. So it allows you to get to the answers that much faster. Here's the example we looked at earlier, just kind of spelled out for you. Identify the unencrypted objects, copy them to the same bucket with encryption specified. And then in this case, a user might want to retain the completion report for all those objects to then have a record of everything that was done. And batch operations plus Lambda opens up a ton of possibilities because of how flexible batch operations is, and of course, many of you are familiar with Lambda and how much you can do with that service. So the baseline way to do a manifest is a list of S3 objects. But we give you some flexibility. So if you want to do copy operations and change the key names of objects, you could write that in such a way where you've got the source and destination key in the manifest, and then your Lambda function unpacks that and actually kicks off a copy operation with those values plugged in. There's an example of that in our documentation. And the last one, for those of you that are already using Lambda in a big way today, maybe you're testing a Lambda function, you want to see how it behaves with different inputs, just use batch operations, create a manifest with all the different inputs you want to see in your Lambda function, and then just use that to trigger Lambda. Kind of a cool batch invocation mechanism for Lambda functions. That could open a lot for you too. And then with Lambda functions, what can you do within them? We've got these managed machine learning services like Amazon Recognition that then I say, I've got all these images in S3, run recognition across all of them, and now take those results, metadata, celebrities found in the images, all these different rich metadata about my images that before I didn't know much of what I had in my bucket. Now I've got all these classifications, labels, sentiment analysis, things like that, and I can put it in Elasticsearch to search it. I can put it in Dynamo. You can do all those things through your Lambda function to say, run this service, find the results, store them here, 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 tons of flexibility with Lambda. The next one's doing things like copying objects, but maybe a different encryption type, maybe different tags on the objects, depending on what we know about the object and depending on what the key name is. Or you could certainly write your own custom code for Lambda. So anything you want to do in bulk on S3. And the one I'll bring together and just remind you of at this stage is S3 events already works really well with Lambda functions. So you might have a workload that's set up every time an object lands in S3, kick off a Lambda function and do this operation. Maybe create a thumbnail. That's probably one of the simpler examples, one of the more common ones. But if you then say, well, I'm changing the way I'm doing that event architecture, and I want to go back to the millions of objects already in my bucket, that's a way to really connect all these features together, run the same Lambda function on those objects that are already existing in your bucket, and now you once again are standardized across your new and old storage. So a lot of cool stuff you can do with batch operations in Lambda. And without further ado, I'll bring on our customer speaker, Matt Wheeler, who will talk to you much more about how real customers are out there using using S3 to run their own businesses.
Thank you so much. My name's Matt. I am a real customer. I am a senior site reliability engineer at Instructure. I'm really excited to be able to share with you a part of our story and to highlight some specific S3 patterns and practices that have helped power our growth. Learning has evolved from a strictly on-premise brick and mortar experience to a blended, sometimes even fully online experience. At the same time, learning itself has become a lifelong journey. Whether it's engaging young learners on their mobile devices where they spend a lot of their time, to outcomes-based education, or for helping workers upskill to switch career paths or gain a promotion, truly we are never done learning. And at Instructure, our goal is to support teachers and learners at every stage of this journey with intuitive, robust, reliable software to help those that want to learn engage with those with the knowledge to teach and then to get out of their way. We make the Canvas Learning Management System, or LMS, for kindergarten through university level higher education, as well as the Bridge Employee Development Suite for the corporate space. As a company, we were born in the cloud. We never had an on-premise data center. We were born in the cloud on AWS in 2008. At the time, I think AWS was like 4 services. We used all of those services then, and we use about 60 AWS services now. We launched generally available production just 8 years ago, but since then we've grown to 30 million users in 70 countries. We operate over 10,000 EC2 instances at peak, and we've got a few petabytes stored on S3. Throughout this growth, we've maintained 3 nines of uptime, which we credit to our cloud strategy. It's enabled us to accommodate over 1 million concurrent users and to do so fairly cost effectively. I'm going to drill down into our Canvas environment and give you a sense of our architecture. Like a lot of companies, we have a monolith and then a lot of smaller services. In our case, for both, we have elastic load balancers that sit in front of auto-scaling groups where we have many EC2 instances comprising a layer of stateless compute. In both cases, we have, for stateful backends, PostgreSQL running on EC2, S3 buckets, of course, also DynamoDB, and RDS. We actually have over 100 clusters of the monolith, so each of these clusters is running the same code as the next, and each of our tenants is assigned to one specific multi-tenant cluster. And we have over 50 different of these smaller services, and they're each running different code from the next because they have distinct purposes. We have a variety of mechanisms for intercommunication between these services in the monolith, including synchronous HTTPS APIs, SQS, Kinesis, and of course, S3. Finally, we've got an ecosystem of extract, transform, and load services, ETL services. This is primarily Spark running on EMR. We have some Flink streaming data as well. These are primarily customer-facing analytics, so helping our users understand better how their institutions are using the platform so that they can get the most value out of it. Typically, our EMR clusters are reading in data from S3, processing it, and writing it right back out to S3. We do not run a perpetual HDFS cluster that exists in between runs of the ETLs. S3 is also the durable layer for our Flink states. There's a lot that makes this interesting that's non-technical also, and this stuff doesn't show up well on an architecture diagram. We're a 1,500-person company now. When I started 6 years ago, I was employee maybe number 300, and we broke into this market by throwing away the rule book that said that learning management systems had to be proprietary software that was run on-premise by each institution. We said we're going to open source our product. But then we're going to offer a software as a service, a SaaS experience. It's so excellent, people will gladly pay us to host it for them. Then we're going to reinvest that revenue into the software and use the control and the flexibility that we have because it's SaaS, because we can directly manage the running software to innovate really quickly and try new things. And putting this all together, we can deliver a global, secure, accessible product that's available 99.9% of the time in your choice of 33 languages and dialects. And as we've grown, we haven't wanted to lose that competitive advantage, that thing that has made us different. So we have a lot of teams. We've tried to keep product development teams really small, give them autonomy to choose the right tools for the job. That means those 50 services we talked about earlier are each owned by one of over 40 or so teams. In production, we've got Ruby and Golang and Scala and Python. The list just goes on. It wouldn't all fit on the slide. Each chosen because it was the correct tool for the problem at hand. This is part of our practice of autonomy. Teams get to choose their tools. We're now spread over more than 40 AWS accounts to provide blast radius isolation and, again, enable team autonomy. These factors, the number of services that we have, the number of teams, the number of AWS accounts, they're actually all reasons why S3 shows up so many places in our stack. Let's look at a very specific example, one I work with every day at Instructure of how we use S3. The red arrow here is going to represent what we call shard data dumps. Shard data dumps. So we run the relational database PostgreSQL on EC2. In some regions, we have over 100 clusters running the database. On each cluster, we have hundreds of shards, so those are separate Postgres schemas, each dedicated to one or a few tenants. Postgres makes a fantastic relational database, but there are times when we would prefer to batch process over this data, and in particular to batch over many shards of data at the same time. And so we dump all of this data to a single S3 bucket per AWS region. So thousands of Postgres schemas, each with dozens and dozens of tables, get dumped to S3. This comes out to be roughly 1 million objects and around 20 terabytes per time we run the dump. We run that dump a couple times a day. We retain several weeks worth of history. We end up with nearly a petabyte in our largest shard data dumps bucket. Do want to note that this isn't our backup strategy for this data. We do use S3 as part of that backup strategy, but this is a method of data interchange that ends up backing quite a few data products and services that we offer. So costs could add up quickly here if we didn't do anything to cull the older data. So to keep costs under control, we use S3 Lifecycle policies to just expire and delete objects after 28 days. There's no muss, there's no fuss. We have that 28-day history when we need it, and there are times when that's particularly useful. But we don't have to worry about our storage costs growing exponentially over time. Likewise, from a site reliability engineering perspective, we have no operational burden of having to manage some daemon that really does need to work exactly correctly because its job is to delete data, and you really only want it to delete exactly the correct data. We use lifecycle policies on this bucket to expire incomplete multi-part uploads. And though it's not applicable to this particular bucket, there are many buckets in Instructure where we do tier things down with lifecycle policies to standard infrequent access and to S3 Glacier. So on the read side, the prefix structure of this bucket was designed so that we could retrieve only the data that we needed on each run of one of these batch processes. Most of our data services don't need all 20 terabytes out of every dump because not all of our customers use all of our offerings. The internal bucket structure allows for the retrieval of just one shard's worth of data, and by specifying the timestamp associated with a particular run of the dump job, you can retrieve just a subset of the data also. So when I talk about multiple services reading this data, that was never the plan. Shard data dumps was created to enable a single data export service a few years ago so that we could provide a customer with a dump of all of their data. But life has found a way, and we now have a dozen or so internal services that consume the same S3 bucket to provide a variety of user experiences. And the thing that I find so remarkable is that the service that writes the data out to this bucket has had to change nearly nothing over that time and throughout that process. What we've accomplished is a fan-out and cross-account pattern that allows us to share this data with all the services that need it. In our model, when a team first wishes to access this bucket, they're probably doing so from their own AWS account. That is not the same account where the bucket is located. And so in order to make that work, the first and only thing that we need to do on the side of the service that is publishing the data is to add that team's AWS account to that bucket policy. At that point, the team can stand up additional services in the future that consume from this bucket by granting the resources in their AWS account read permissions to this particular bucket. This is really powerful because it allows teams that want to solve interesting data problems, sometimes using new technologies, to do so really quickly. We don't get caught up on transport layer issues or credential exchange. There's no lobbing of tickets over to the team that owns the shard data dump service. S3 is agnostic to the specific stack that's consuming it. And again, that allows teams to be autonomous, which is very important to us. To quote one of our principal engineers, I know that if something is in S3, it will cost me effectively 0 implementation time to consume it. It would be completely amiss if I didn't hit on the durability that S3 provides, because it really is the most fundamental thing that it gives us. It opens the door for everything else. At Instructure, our software is the source of truth for course content, for student submissions, for grades. We take data durability incredibly seriously. For those buckets that contain critical data, we turn on object versioning. We make sure that previous versions of objects are not cleaned up automatically for an extended period of time. This makes object deletes and mutations effectively reversible. For our most critical data, we also use S3 cross-region replication to make sure that data is present in multiple geographically distinct AWS regions. We found that with S3, so long as we do our part, the data is still going to be there where we need it to be, and S3 provides features, including these, that make it a lot easier to do our part. So to summarize, S3 is absolutely a critical part of our infrastructure. We use it all day, every day for a variety of purposes. Shard data dumps is just one example of how S3 is a fundamental part of our success. It doesn't just provide for us an excellent technical solution to some pretty weighty problems. It also enables a powerful organizational structure that has helped us to scale our entire enterprise and accomplish our mission of helping people grow from the first day of school to the last day of work. Thank you.
Thanks, Matt. So I think Instructure really has some great examples on how to use Lifecycle to simplify your storage management and save costs. And now I want to review some of the data protection features and monitoring and visibility features that S3 offers. So what do you do to protect your data? I think on a high level, we all have some idea of what we can do. So you can create copies of your data. You can keep versionings. You can enable versioning so you have multiple versions of your data. Or you can just lock down your data for any modification. And S3 has a couple of data protection features that help you do that. So we have replication that help you replicate all the objects in a bucket for compliance purposes or protection from rogue actors. Or you can enable versioning to retain the previous versions of your object. Or you can use object lock to actually lock down your objects for governance or compliance purposes by writing them in write once, read many form. Let's start with S3 replication. So S3 replication is an automatic and asynchronous process that creates identical copies of your objects, in retaining all the metadata that is on the source object, including your creation date and time and version IDs. So since S3 cross-region replication launched in 2015, this feature has replicated trillions of objects and exabytes of data. Customers asked us to extend this capability so that they can have a destination bucket in the same AWS region as the source bucket, and we recently announced just that. Let's take a closer look at how you can best use the capabilities of S3 replication. S3 replication gives you the choice to replicate all the objects in your bucket, or you can choose a set of objects that are under a given prefix, or you can choose a set of objects that are identified by a tag of your choice. A best practice is to use this object-level granularity to save costs by replicating only what you need to replicate. Once you have selected your source data set, you can choose a destination bucket in a region of your choice. You can make the replicated data more secure by using ownership overrides for your replication, for your replica copies, or using cross-account replication so that no single user or account can accidentally or maliciously delete all the copies of your data. Depending on the use case of your replica copies, you can either store them in frequent access storage classes, or if you know you're not going to access them as much, you can directly replicate them into an infrequent access storage class or archive storage classes like S3 Glacier. Because data access patterns are often different between the primary and secondary locations, you can think about implementing different lifecycle policies across your source and destination buckets and optimize your cost. So replication begins as soon as you upload an object to S3 that is covered by a replication policy. And customers are often interested in the time it takes to finish replication, which can be influenced by number of objects you're replicating and the size of objects that you're replicating. So for critical workloads where you need this additional control and visibility over replication time, we recently announced S3 replication time control feature. Replication time control predictably replicates 99.99% of your objects within 15 minutes of upload to S3, with most objects replicating in seconds. This replication performance is backed by a service level agreement that covers 99.9% of your objects within 15 minutes in any billing month. Replication time control builds on and works with all the capabilities of S3 replication and adds a new set of CloudWatch metrics that gives you insight into your replication activity. Let's take a look at what these metrics are. So these new replication metrics that you can view in S3 Management Console or CloudWatch actually gives you the number of objects that are pending replication, the number of bytes that are pending replication, and the maximum replication time to the destination. These metrics are provided for each replication policy you configure with replication time control. So replication requires another S3 data protection component, versioning, to be enabled on your buckets. You can use versioning to archive all the previous versions of your objects to restore them in case you have accidental deletion or accidental overwrites. So let's take an example here. What happens when you're putting an object in a version-enabled bucket? With each new put for that object, S3 actually generates a unique version ID, and all the previous variants of that object are retained in S3. So with the new version, you have an object with a new version ID, and both the copies of these objects are retained. This also provides protection against accidental deletions. What happens when you delete an object in a versioning-enabled bucket? S3 actually retains all the previous copies and adds a 0-byte object called delete marker. So if you do a get for an object that's deleted, you would get an HTTP 404 not found error. The caveat is that you can restore or permanently delete any version in S3 by mentioning the version, by specifying the version ID in any request. So some things to keep in mind. Now that you're keeping multiple versions of your objects, you're also paying for storage. Best practice is to lifecycle policies to expire previous or non-current versions after a set period of time, something that Matt also is doing in Instructure. This example shows how to set up a lifecycle policy to expire older objects after they have been non-current for 7 days. So an object version becomes non-current as soon as you upload a successor version for that object. In addition to expiring older versions of objects, 2 best practices are to use the lifecycle policies to clean up incomplete multipart uploads and to clean up expired object delete markers. And you can easily see them in S3 Management Console when you are configuring your lifecycle policies. You can also reduce your costs by moving the previous or by transitioning the previous versions of your objects to an infrequent access storage classes. If you're not frequently accessing the previous versions of your objects, a good idea is to transition them to a less frequently accessed storage class and save costs on that. Now let's look at object locks. Another important data protection feature is object lock, which gives you the flexibility to set retention controls on individual objects or all objects in a bucket by using bucket defaults. So object lock features multiple retention modes that apply different levels of protection. So you can see compliance mode. In compliance mode, an object version is protected from being overwritten or deleted for the duration of the retention period. Also, in compliance mode, no user can delete or override the object or alter the lock settings, not even the root user in your AWS account. Coming to governance mode. Governance mode actually provides the same protection. So an object cannot be overwritten or deleted, or lock settings cannot be altered, but you can give some users special privileges to alter your lock settings or delete the object if need be. You can also use governance mode to test your lock settings and then actually enable compliance mode. Legal hold is another option that provides the same protection as retention period, but there is no expiration on legal hold. So your object stays logged until you explicitly remove the legal hold. Even though the setting is called legal hold, it's basically useful for any use case where you don't know when, until when you want your objects to stay in immutable state. So an example could be you have an external data audit, and you want your teams to not touch your data until the audit is over. You can put your objects under legal hold and then explicitly remove it when the audit is over. You also can track access and changes to your log configurations via Amazon S3 events and CloudTrail. And you can use CloudWatch to generate alerts based on this event data. Finally, let's cover some monitoring and visibility tools that provide insights into your storage and the performance of your applications using S3. So we talked about S3's new replication metrics earlier, but S3 provides more CloudWatch metrics that you can use to monitor your storage. The first in this category is daily storage metrics. So daily storage metrics tells you how many objects and how many bytes you have in each storage class in your bucket. These metrics are reported once per day and are available to customers at no additional cost. The second in this category are S3 request metrics. S3 request metrics can be used to quickly identify and act on any operational issues. So you can see a few examples here where you have operation counts by categories, how many put requests I had, how many get requests I had. You have bytes downloaded, bytes uploaded. You have HTTP error counts by categories as well. And you have request latencies. These metrics are available at 1-minute intervals, and you can apply filters like object prefix and tags. So you can align these metrics, you can use these filters to align your metrics to specific business workflows or applications or teams in your organization. So earlier we had, for S3 request metrics, we had statistics like average, minimum, and maximum. In July this year, we launched percentile support for these metrics in CloudWatch. And percentile metrics, percentile statistics are particularly useful to understand the variation of your metric, and they help you understand what are the actual outliers in your request so that you're not spending your time chasing false alarms. They can help you identify the experience that most of your users see. Percentile metrics is one another example of how S3 continues to invest in its features to make them better. I think this brings me to the end of our presentation. On behalf of S3 team, I want to thank you guys for using S3. Hope you enjoyed this session and hope you have a great time at re:Invent.